go. Okay. Hopefully we can get this in before the battery dies. So now we're going to focus. So we looked at inverses two ways. We looked at inverses as being a reflection in the line y equals x, where we took that radical function and flipped it over. We talked about how you can find an inverse by taking the x and y columns and switching them. Now we're going to talk about how to find an inverse algebraically, and this is a step-by-step process for how we can do that. Okay, you're going to be given a function. We're going to go through 3 examples. I'll probably do 3 different videos. Okay, we're going to go through examples where we have a function written in terms of f of x, change the f of x to a y. Very simple step, right? Literally just take out the f of x, put a y in its place. Then we swap the x and the y's, we solve for y, and then the last step, again, you just change the y to an inverse notation that looks like that. And this really emphasizes the idea of undoing. Because when we do this, when we solve for y, we undo all of the operations that were in the original function. Okay, so I've got my examples here. So we're going to start simple and then we'll build our way up. Okay, and then when we meet again, we'll even kick it into higher gear. So here's a function, f of x equals 2x minus 5. Very basic linear function here. Okay, when you look at function f, what does function f do? Function f takes its input, it doubles it, and then it subtracts 5. So in my mind right now, knowing what we've talked about in terms of inverses and undoing, the inverse function of f is going to have the inverse of this, which would mean I'm going to be dividing by 2. And it's going to have the inverse of this, which means there's going to be a plus 5. Now how that looks when I write the function depends on how we go about solving this. So let's go through this step by step. Change the f of x to a y. That's a simple step. Then we swap the x's and the y's. Everywhere we see an x, I'm going to change it to a y, and that one y becomes an x. You may have more than one x to turn into a y. That's not the case now, but down the road it will be. Now we solve for y, like we're solving for a variable, right? We add 5, and we add 5. So we have x plus 5 equals 2y. And we divide by 2. Divide by 2. We get y equals x plus 5 over 2. So you can see here, this is our inverse, right? The last step. We solved for y. Now write y as the inverse function of f. So we're done. So when you look at this inverse function compared to the original, in here I have division by 2, which is the inverse of this, and I have addition with 5, which is the inverse of that. So this is what we mean when we talk about inverses being the undoing of a function. We need to see the operations that are here being undone in the inverse. Okay, now this is about as simple as they get. We're going to try a couple more complicated examples here in some of these other videos.